Hello, I'm Himanshu Nigam from IIPS and DAVV University, Indore, and here I'm presenting our NAD Internal 1 solutions. Our question 3 is, calculate the value of polynomial for x equals to 4.0110 using floating point arithmetic with four mantissa using two approaches and compute the relative error with using straightforward determination method and nested parenthesis method, where px is given by x cube minus 4x square plus 0.1x minus 0.5. Here our solution is, first we'll use straightforward determination method. Now first of all, in this method we compute first term, which is x cube, and putting the value of x 3 times we get the value 0.6449 E2. This is our A equation. Now calculating for the second term is equals to minus 0.4000, and putting the value of x 2 times we get minus 0.6435 E2. This is our B equation. Now our third term is 0.1x. Putting the value of x and multiplying we get 0.4011 E0. This is our C equation, and finally our last value is minus 0.5000 E0. This is our D equation. Now adding the equations A and B, we get x cube minus 4x square equals to 0.1700 E0. This is our first equation. Now adding equations C and D, which is this 0.1x minus 0.5, we get value minus 0.0989 E0. Now here adding the equations 1 and 2, we get the whole equation 0.7110 E minus 1. Now this is our final value of the equation. Now using nested parenthesis method, the given equation can be written or can be split in the form of like this: minus 0.5 plus x into 0.5 minus 4x plus x square, or it can be simplified as minus 0.5 plus x into 0.1 plus x into bracket minus 4 plus x, and we close the brackets here. Solving this polynomial in parts from right end, we get here, using the rightmost end, which is minus 4 plus x, we get the value 0.1100 E minus 1. This is again our equation A. Now multiplying next step, which is x, to this, we get the value 0.4412 E minus 1. This is our B equation. Now adding here, adding 0.1 to B, we get the value 0.1441 E0, which is our C equation. Now here again from the formula we can see, multiplying x with C, we get 0.05779 E1. This is our equation D, and then finally adding minus 0.5 to D, we get the value 0.7790 E minus 1. Hence we can write x cube minus 4x square plus 0.1x minus 0.5 is equals to 0.7790 E minus 1. Now to find the relative error, we have to calculate the value of polynomial using 8-digit arithmetic. Let us see how we can do this. Yes, computing x cube by multiplying x 3 times, we get the value here like this: 0.64529453 E2. This is A equation. And then getting the value of minus 4x square, we get the value minus 0.64352484 E2. This is B equation. And then again finding the value of 0.1x, we get the 8-digit arithmetic as 0.40110000 E0, and minus 0.5 remain as it is, but in 8-digit arithmetic. Now this is our D equation. Adding A and B, we get 0.00176969 E2. This is first equation, and adding equation C and D, that means this and this, we get the next step of our equation, like 0.1x minus 0.5, we get minus 0.09890000 E0. This is our second equation. Now adding the first and second equation, we get x cube minus 4x square plus 0.1x minus 0.5, we get 0.7807 E minus 1. Now percent error in method 1, that is straightforward determination. We get putting the value of current value minus previous value divided by current value into 100 is equals to, we are getting here 8.9%. Now percent error in method 2, that is our nested parenthesis method. On putting these values, 0.7807 minus 0.7790 divided by 0.7807 multiplied by 100, we are getting 0.2%. Now the second part of the question says that develop an algorithm to find cube root of any number using any method like bisection, false position, or any method. Our solution here is, let x equals to cube root of n. Okay, now where capital N is number whose cube root is to be determined. Now here we can write this as x cube is equals to n. Thus fx would be x cube minus n equals to 0. Now bisection method, we are using here bisection method to find the root. The algorithm for this method is, first of all we read x0, x1, that is our interval, and the error. Here x0 and x1 are two starting points which encloses the root, and E is the error allowed. Now we put the value of f of x0 into y0 and f of x1 into y1. Now we start our iteration with I initialized to 0. Then we check for the if condition. If sign of y0 is equals to sign of y1, then we write starting values are unsuitable, or this is an invalid interval. Now we write the values of x0, x1, y0 and y1. Now we end this condition. Now we check for the while condition. While mod of x1 minus x0 divided by x1 is greater than E, which is our standard error, which is 0.0001, we put the value of x0 plus x1 divided by 2 into x2 and the value of fx2 into y2. Then again we increment the iteration by 1. Now if we check for the another condition, if sign of y0 is equals to sign of y2, then we put the value of x2 into x0, otherwise we put the value of x2 into x1. Now here the if condition ends. Finally we write the solution converges to a root, and then we write the number of iterations, which is I, and then we write the value of x2 and y2, and here our algorithm stops. Now that's all for NAD Internal 1 solutions. Thank you.